Ayo, OA, welcome to the Daily Space Weather. I'm your host Dan, aka smAsho. And today we're looking at solar flares and coronal mass ejections once again in the smAshlght segment, and the Snowman cometh. And first thing we're going to do is we're going to look at this. Oh my God, NASA is obfuscating the sun. They were trying to hide those solar flares, but it didn't work out. You see that? They tried to put their little fake moon disk in front of the sun there. Oh my God. It's a shame they failed so hard. Anyway, here's the 94 angstroms SDO video. Just kidding, folks. It's actually the moon. And we saw some solar flares here, some C-class flares happen right in that time frame, kind of close together. And so we've got some more views here for you on HelioViewer. There's a quick view of the fields and 171 angstroms and 304 angstroms. Again, here's the magnetic field environment. There's the latest image. And we saw some coronal mass ejecta here. It looks like it'll all miss to the northwest, or certainly most of it. We don't expect it to be what we would call geo-effective. Here's a full disk view in 304 angstroms, and you can see that coronal mass ejection happened. Don't worry, we'll have a close-up of this in a minute. There's a couple C-class flares and a coronal mass ejection happening at the same time there. You can't really see the coronal mass ejection on this view, but you can see the flares down in the lower right. The leading edge of that former sunspot group, not out of the current sunspot, which is also a thing to take a look at, but the main activity, a series of high-intensity photons coming out of the setting region. And there's a reason why we see that, and there's a still frame of one of those C-class flares. So a great close-up here in 304 angstroms. And you can see some ejecta from this view. Great view of the ionized helium situation. We'll let that play through one more time here. And thanks again for tuning in, everybody. Let's get to some more data here. I wanted to briefly talk about cosmic rays, as it seems to be a thing everybody is suddenly very interested in, as they don't seem to understand the data. Notice the way spaceweather.com very carefully worded this. Their conclusion is that it's at a 5-year high. It shows a 15% increase since the program began in 2015. Why are they saying it that way? Well, it's because cosmic ray flux is not as high as it was in 2010. And we look at various cosmic ray observatories. Check it out, the radio flux is all the way up to 77. So we've seen a big increase in the radio flux here, as we see two active regions on the sun, one producing flares and one producing sunspots at the same time. So the 10.7 centimeter radio flux now above 75. And for you new viewers, that is a proxy for sunspot number. It's radio output of the sun's outer corona. KP index, a measure of global geomagnetism, currently at 2, and there you can see those two C-class flares, as well as a couple of B-class flares, 3 of those as well. So a little ramp up and ramp down there. And by the way, you're actually more likely to see flares when a sunspot or active region is closer to the edge of the solar disk, as opposed to in the middle in the Earth-facing zone, because of the way that metals emit photons. So if you're looking at a very flat metal surface, it's very unlikely to emit photons directly in your direction, especially if it's made of a hexagonal metallic lattice, as apparently the surface of sunspots is made. So this is part of the reason why we call a thing the Earth-facing quiet effect a thing. It's sort of a misnomer. It just has to do with the emission spectra of metals. We don't see any major proton events happening right here. But again, there have been some coronal mass ejections, just not Earth-facing. Looking at the real-time solar wind and checking on the life of the stream before we move on. Gonna take a look at the phi angle here, which has recently shifted a little bit. Nothing too crazy going on there. BT/BZ has recently shifted. Current BT/BZ is, the BZ is quite convergent on the zero line, indicating that both the north and south field, the north and south solar polar field, are both exhibiting a similar amount of influence on the total field strength, which is the BT, which is currently at 7. Pretty nominal values there, nothing too exciting. Current solar wind density just under 10 protons per cubic centimeter. Current solar wind speed 315 kilometers a second. Geospace is looking pretty normal here, and you can forecast a little bit about what this would look like in most situations. And let me just take a moment to talk about the galactic current sheet, because this is a great view. So let me just bring out Epic Pen here, and we'll actually look at the geospace ground magnetic perturbations, and then I'll talk about the, quote, galactic current sheet, end quote, because I know we've got a lot of viewers who view other YouTube channels who like to fearmonger about certain things. And today's fearmonger debunkage, and we do see significant magnetic perturbations here, by the way, coming out of the Pacific Ocean. You can see there a little south of Hawaii, very close to Hawaii actually. So some major magnetic perturbations there. And also, you know, you're living through a magnetic excursion right now, so the South Pole has migrated, the South Geomagnetic Pole, that is, has migrated into the Indian Ocean here, south of Antarctica. I mean, south of Australia, in this area. And the North Pole, we've actually got 2 of those. We've got one over Canada, one over Siberia, and the net pole is someplace in this area. So, let's talk about the galactic current sheet, end quote. So, this is not to scale. Here's the surface of the sun, right? The surface of the sun is constantly blowing out a solar wind. And that is what is causing the Earth's magnetosphere to behave as it is. If you looked at this as the sun and the core of the galaxy over here, that's nothing like the solar system. The amount of distance in between the sun and the Earth versus the sun and the galactic core, it's not comparable. And the sun is not interacting magnetically on a particle basis, on a radio basis, or on an X-ray basis. It's not communicating with the galactic core. It's largely orbiting the galactic core based on inertia. And so these ideas that the sun is passing up and down through a galactic current sheet is completely ridiculous. It makes no sense, and it demonstrates a lack of understanding of the way particle physics and magnetohydrodynamics work. Plasma is not magic, and even if it was magic, there's no plasma bridge between the sun and Sagittarius A star. Deal with it. If Sagittarius A star is interacting with the solar system in which you live, it's doing it via the spiral arms, not some mysterious galactic current sheet, because that's not a thing. So this is a depiction of what the heliospheric current sheet's magnetism looks like, and there is nothing like that at all in between you and the galactic core. If there's any interaction between you and the galactic core, it's through some sort of poloidal field process, and it would be through the spiral arms, because there's nothing to connect you. to Sagittarius A star. There's no mysterious invisible Birkeland current out there. And again, plasma is not magic. Let's get back to data. Dego's magnetometer. There's the 3-day chart of that. And we've been in an indecisive zone here between north and south current sheets. Now pretty solid in the north current sheet finally. An indication that sunspot 2776 is probably a weak sunspot, and we're not expecting it to intensify based on this magnetic data derived from the National Sunspot Observatory. Here's a line of sight field plot which shows you the B field in blue. And it shows you the poloidal fields, which I was referring to earlier, in green and red. And these poloidal fields blast out jets of protons constantly. So there is a coronal hole at both ends of the sun with an ongoing proton stream coming out. And there's likely matter coming in too. Ultimately, we don't know if the sun is gaining or losing mass. Not to mention if the Earth is gaining or losing mass. And by the way, some of those cosmic rays that are measured at Antarctica are coming out of the planet. And it all has to do with the fact that these objects are made of condensed matter. And it explains everything from geomagnetism to the behavior and spectral analysis of all stars, but especially the sun, since it's the Rosetta Stone of all cosmology. So here's the coronal magnetic field plot, showing you the magnetic fields of just the corona. And this is different than the other ones in that we're not looking at the entire heliosphere. We're trying to look at just the corona here. It shows you closed potential field force lines in pink, coronal hole potential field force lines in purple, and open potential field force lines in black. And it shows you net B field lines in green. I don't know what helmet streamer belt means. I guess it's referring to what we would call the B field in here. And in any case, today's smAshlghts is actually part of the Scrying with smAsh. So if you've never seen Scrying with smAsh, I'm very angry and the place is about to burn to the ground. But I will put out the fire and suggest that you see our crystal ball readings in the Scrying with smAsh playlist. Also, don't forget to visit our links, smashamash.com and so on. We've got an Amazon affiliate, smashamash.com/affiliate. We've also got a new shirt design. This is based on an old one, but we've changed it up along with the color offerings. Congratulations on surviving a global pandemic so far. This one comes in only purple and black, and this other color scheme only comes in lime green, black, gold, and white. So that's gold, baby. Just like your survival of a global pandemic. And again, congratulations. Let's talk COVID. Actually, let's not. It's statistically irrelevant. Do you follow us on Instagram? You may see pictures of James T. Kirk sucking on a ghost. Instagram.com/smashamash. We try to keep some exclusive content, and we do regularly talk cosmology. Let's talk cosmic rays. Yes, as we look at the actual data, we just don't cherry pick the data. And apatity is showing a little uptick here over the past one day. Now watch for it to downtick way down to here in the next 2 days. There's the 1-day apatity. Here's the 30-day Barentsburg, and you can see a downward trend at Barentsburg. Also, we'll look at Athens, Greece, a little bit farther south. By the way, it's all pressure-corrected data. And whoops, Athens has been showing some erroneous data here on the regs over the past couple of years. Here's Mexico City, a little bit more variable. Also pressure-corrected data, by the way. And slight uptick there over the past 30 days, but quite minor. And lastly, let's take a look at what's going on with Moscow. Let's see if Moscow's got their monitor back. And they're showing cosmic rays from (2019), although it says 2020. That's some fake Russian data there for you, folks. Don't fall victim to the fake Russian data. They might be trying to frighten you with a bunch of nonsense. Lastly, we'll take a look at the OLU neutron monitor, which, by the way, is displayed on spaceweather.com. That's why they're wording their statements about cosmic rays so carefully, because they don't want to appear to be misleading folks that view the channel, or that view their web page in their case. But I would cite this little area right here and this little area right here. Yeah, that's the trend that we see on pretty much all cosmic ray monitors. So I don't know where this mysterious data that people like Ben Davidson are talking about, but I don't see it. All I see is people saying 60% of cosmic ray monitors indicate higher levels. I just don't see those monitors or the levels, and I've made custom graphs about it. You can find them at the Twitter page if you like, I guess. Today's featured cosmic ray source is Deneb, and if you view this on different scopes, this is the Pan-STARRS. You may see anomalies going on with it, and it's because, well, it's a high-mass X-ray binary, and those are interesting. Let's just say that. Deneb is the brightest intrinsic object visible from Earth, at least within the Milky Way galaxy. There are the X-ray emissions from it, and it's just coming out of its quiescent state here. You can see it's about as low as it ever gets, way down at the 0 line. And what it typically does is shows the highest X-ray flux that it ever shows just after those states, ramping up and up and then up more, but staying variable within a 4.79 hour periodicity in the meantime. And we monitor this one daily at the Neil Gorell Swift Observatory. If you want to read all about Deneb, aka Cygnus X3, head to smashamash.com/forum. There's a whole cosmology segment there about it. That's all we'll talk about cosmology. Let's talk about social media. I recommend AltTech. Minds.com is pretty interesting. For example, I actually found Oppenheimer Ranch Project as a result of using Minds.com. So yeah, all of you viewers out there that view both of our channels, I don't know what to tell you, but here at the Smash News Network, we're not going to, suggest things that aren't true, for example. Anyway, at minds.com/smashamash, we've got links to the new I've Survived a Global Pandemic So Far, which is, I believe it's called Smash Survived 3. Also, don't forget to check us out on Twitter, twitter.com/smashamash. And when you buy a shirt, don't forget to enter the promo code MANSA. On checkout, you'll save 10%. That's $250, I think. What's going on with U.S. senators? Who votes for these people, much less trust them to legislate? Jeez. What is up with that? By the way, we typically stream live to Twitch. I'm surprised we still have 52 followers over there. Don't people have hundreds of thousands of followers on Twitch? If you enjoy the content on YouTube, press like and subscribe if you're able to see the videos, which I imagine you would be, otherwise you wouldn't hear what I'm saying right now. Leave a comment, press like, press subscribe, etc. Also, thanks to our new subs at BitChute. BitChute.com/smashamash. Here ends another SmAshlghts. It's all integrated. Well, let's get back to spacey stuff. Are you spaced out? Are you a spaced out viewer? Well, thanks for tuning in. Here's some electron flux data. And we're talking about things like the Van Allen belts. There are the relativistic electrons over the past year. And we're in a very low range here. We don't see charging hazards. Oh, we do see a little bit of minor charging hazards there over Mexico. And we're expecting a fairly flatlined electron flux here, as we've seen pretty low levels of solar activity. There's the 3-day chart. And here's the visualization of the full air column all the way up to the thermosphere. And we see once again some anomalies over North America. You see those anomalies there? Some high levels of electron flux at nighttime around the North Polar region, as well as over the Middle East there. And one of the scariest things about setting off nuclear weapons in space, folks, is that we would actually see those electron flux regions as little clouds that sit still. It's pretty weird, especially if you understand the implications of it. Let's look at just one slice of the atmosphere, since that was the entire atmosphere in terms of electrons. Here is just the ionosphere layer, and this is in megahertz, by the way. And we see quite a heavily charged up ionosphere here, as well as anomalously charged up nighttime ionosphere. So you see these significant anomalies here over the South Pacific. Here's the latest image. And we are streaming live to Twitch, by the way. So if something goes wrong, it could be a complete disaster. You never know what'll happen. Here's a star chart. I like to use in-the-sky.org. If you're up before dawn, you may see Venus and Mars. Happy new moon. My favorite phase. I usually sleep better. An indication that I need darker curtains. What say you? I'm a bit of an expert on sleep and dreaming, by the way, folks. I started studying that a long, long time ago in the 1980s. When you're a teenager and you read 80 pages of Encyclopedia Britannica about sleep and dreaming, you've got a good base. Anyway, here's the current earthquake situation. We've got a deep quake in Afghanistan to start the list. Very deep quake near the Fiji Islands at over 550 kilometers at a 4.7 magnitude. Largest of the past 24 might be this 5.4 at the Philippines. I'm not exactly sure, as I'm finding this out as I tell you. Another deep quake at Afghanistan. And we've seen consistent deep quakes at Afghanistan and no large ones at the surface. Here's a 4.6 at Indonesia. It's at 143.3 kilometers depth. One in the Greenland Sea at a plate boundary between the European and North American plates. Anyway, there's the rest of the list. Volcanoes have upticked a little bit since yesterday. Suwa-no-Sejima back on the list. Volcanic ash cloud unknown, Semaru. Flight level 130. Carinthia exploding, flight level 150. Popocatépetl exploding. 18,000 foot ash plume there. 18,500 foot ash plume there. Sabancaya also exploding, emitting a 27,000 foot above sea level ash plume. Please do not attempt to fly your homemade kit aircraft over that caldera. And share us on your social media instead. Check it out. We got lots of red flag warnings here in the Corn Belt, as well as some hard freeze warnings and some winter weather advisories there. Here are some forecasts here, tropical tidbits. Check out Cuba. Cuba's going to get hammered with rain. Forecasting for like 2 feet of rain there in Cuba. Bad times. Let's see if CNN blames communism for that 2 feet of rain. Also some snow and rain falling in the north central U.S. That's the forecast through Thursday, October 22nd. And there are some spots there that are forecasting about 18 inches of snow, it looks like, in North Dakota and Minnesota. Expect some snow in some of those regions. There's a forecast through 12 Universal Time, Tuesday, October 20th. Montana is going to be coated. And check it out, we're starting the year 2 standard deviations above normal, where we've been for the last 3 winters. So there you go, a prime example. I'm forecasting this is going to be a little bit lower this year than it was in 27 to 2018, 2018 to 2019, and 2019 to 2020. Why? Well, I've got one more example of why. Now, of course, I never know who may be watching the videos. You just never know. But if you head to spaceweather.com, there's another interesting data here that you may be interested in checking out. It's the Thermosphere Climate Index. Allow me to vanish, because here at the Smash News Network, the importance is the visual aids, not being on screen. So, check out the Thermosphere Index. Thermosphere is sort of the uppermost atmosphere. And notice how much warmer it is here than it was at the last solar minimum. You see that? Much colder? Yeah. Well, thermosphere warmth equates to all kinds of things when it comes to space weather, because how hot the uppermost portion of the atmosphere is really figures in. And it really figures into people who understand solar forecasting. And it really figures into people who understand heat latency. And the Earth's heat latency is almost entirely in the oceans. So anyway, moving on. Back to snow. Here's the multi-sensor snow and ice cover. It looks pretty snowy. I don't know. It looks pretty snowy to me. Are you worried about Greenland melting? There's been 5 meters of snow from coast to coast all summer, the last 3 summers in a row. I don't know if you've actually looked at the data, but it's there for the picking. Anyway, here is the water vapor map for the Americas. And there it goes. Here are the jet streams of the Western world. Significant low pressure system there and some cold air blowing down toward Bermuda, making for maybe some good surf and some cold days. Get your wetsuit. Bermuda, usually a bad place to surf, believe it or not. Next, the eastern world's jet streams. And we've got a bit of an anticyclone over the southern Indian Ocean. Yes, it's rotating counterclockwise, which in the southern hemisphere means, I'm sorry, that's an anticyclone. Yes, it's a high pressure system. An odd one, actually. It's a little anomalous. And here's pressure systems for the whole planet. Here's where they'll be at 1 p.m. Kickoff time tomorrow for Eagles versus Ravens. At least according to the GFS forecast. And before we continue on to see where lightning's been striking, allow me to reappear back from my home plane of existence. Please leave us a comment if you're viewing from a different plane of existence, universe, etc. We greatly appreciate your viewership. If you're viewing from a spacecraft, perhaps one that Gina Maria Colvin Hill has sighted, please leave us a comment. I like to use lightningmaps.org when I hear thunder. Here's a US Doppler Radar Map. And that is totally not updated. That's like yesterday's map. Because I'm like, it better not be raining like that. We've got some wintry mix in western PA, as well as a whole bunch of snow falling over Montana, North Dakota, Minnesota, and Wisconsin. I bought about 4 pounds of cheese yesterday. So that's why I never go on vacation to Wisconsin, because that's a place that you want to come home from, no matter how good the cheese is. Here's a water vapor map, and we're going to zoom in on northern Wyoming, as it is the point of most resistance, or in some ways least resistance, as we've got a massive pressure gradient right there and right there. If you're flying a plane over those areas, expect to feel like you're driving a bus down a bumpy dirt road. Yowzers. And a bunch of cold mass of air being injected down here from Canada, making for some wintry conditions. zoom in on the Great Lakes region also here real quick for all of you Northern Plains nabs. North Central. North Central? North Central. And it's going to get cold in Pennsylvania. It's going to get cold where I am. And for you new viewers, I'm located in Lehigh Valley, Pennsylvania, about where the purple dot was. Thanks to our patrons, a real source of funding for the content. Please consider becoming a patron and helping to fund our operations. It's patreon.com/smashamash. You'll get bonus features. And we've got lots of bonus features. Don't forget to check out our affiliate links, smashamash.com/affiliate. Thanks, Smash Team, for tuning in. Remember, share the content. Check out the new shirt. Don't forget to enter the promo code MANSA on checkout to save 10%. There's the new design. Here's me vanishing. Thanks for flying American Smashways. Keep your head and arms inside the Smash plane, because we've got bonus features, as we always do here at the Smash News Network. We've got the colorized magnetogram, the intensitygram, and a 335 angstroms 48-hour SDO animation. And we've got a growing region down here, so I believe this is going to remain beta class for now, and we could see a ramping up of the activity as I speak. So yep, that umbra is actually more defined than it was, and that will remain a beta class sunspot for the foreseeable future. And when I say foreseeable, I mean like the next 6 hours, maybe more. So maybe some activity making way for that. I also see some brightening here around the rim, right in that area, an indication some more active regions could be rising. Don't forget to keep an eye on that star. And when I say ion, well, the pun is intended. And up on the left there, that's not a spaceship. Anyway, we're out. Thanks for tuning in. And may that solar wind be at your back. Smells like hyacinth and bananas. Ah, the COVID 2020 vintage. Made in China. 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 China, 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 China.